Hi Bobcats. In this video, we're going to take a look at logarithms. This is something that I find students have very different backgrounds on. Some people come in being really strong and confident with logs, and other people are like, log, that's like something you put in a fireplace, right? So if you haven't seen logs before, please don't be intimidated. The way that we use logs is very straightforward, and honestly, for the most part, it's just a button on your calculator. But I'm going to attempt to explain a little bit here about what logs mean and how we use them. The two big places that we will use them in chemistry are for pH calculations, which will be in the chapter on acids and bases, chapter 16, and in kinetics, which is chapter 14. The first type of log we're going to tackle is known as base 10 logs, and it's written log. All this means is we're trying to figure out what exponent to put on 10 to give us back the value that we're asked to find the log of. So for instance, here where it's saying that the log of 1,000 equals, well, what we're asking is basically 1,000 equals 10 raised to what power? We're trying to figure out what power that is. Well, if x was equal to 3, 10 to the third is the same thing as 1,000. So the exponent is the log. So the log of 1,000 is 3. For the log of 0.001, well, instead of being 1,000, that's 1/1000th. So 0.001, sorry, turn my phone off. 0.001 is equal to 10 to the x is what we're trying to find out what that x is. What exponent do we put on 10 to give us back 1/1000th? Well, that's going to be -3. 10 to the -3 is 1/1000th. So the log of 0.001 is equal to -3. So taking the log of something and 10 raised to that something are opposite math functions, just the same way that multiplication and division are opposites and addition and subtraction are opposites. Most calculators put the log and the 10 to the x button or 10 to the x functions on the same button. So on this particular calculator, which is one of my favorites, it is right here. You actually can't see that very well. Let me try yellow instead. Right, so right here, this is where we have log and 10 to the x. The second part of this presentation is going to be about natural logs, and that's the key right next door. The natural log and the e to the x are opposite functions. There are so many different makes and models of calculators, I can't even begin to address how each and every one of them works. So it's really important that you know how to do this on your calculator. So grab your calculator. On the next slide, we're going to be doing some practice with that log key. Here we go, calculator practice 1. Okay, so two things we're going to do with that key. We're going to take the log and we're going to take 10 to the x. So on the basic scientific calculator, the way that you would type this in is first you would type in the number, which would be 42, and then you would hit the log key. And so when I do that on this calculator, 42 log, now my display says 1.62. Whoops, I wrote a 3, but it actually says 2, 1.62. I'm not going to obsess about significant figures in logs right now. For those of y'all who are very interested in significant figures, whatever number you're taking the log of, you count how many sig figs it has. So 42 would have 2 significant figures, and then that becomes the number of decimal places in your answer. So 2 decimal places because the 42 had 2 sig figs. Now, if you have one of those calculators that is designed to operate like a graphing calculator, but it's not actually a graphing calculator, right? Because for Chem 1342, you can't use a graphing calculator. The other calculator, it types these in a very different order. You would type the log button first, and then you would type a 42, and then you would have to close the parentheses, and then you'll have to hit enter equals something like that, depending on your particular calculator. All right, so let me go through, work a couple more of these. Please, please, please work these on your calculator and make sure you're getting the right answer. So for that second one, I would type in 0.00125 and hit the log button. And that's giving me a negative 2.903. Anytime the thing you're taking the log of is smaller than 1, you're going to end up with a negative value for the log. And again, that had 3 significant figures, so I ended up with 3 decimal places, but that's not anything I'm going to worry about quite yet. Let's just see what I'm saying in class when we're doing logs. All right, and then last but not least, when we're working with pH calculations, after you take the log, you also have to change the sign. You'll see that there's a negative in those equations, so this is the same number from up above. So if we take the negative log, we end up with 2.903. Over on the other side, going in the opposite direction, we have 10 to the x. And so with 10 to the x, we're looking at the second function on that key. So what I would do on my basic scientific calculator is I would show the 2.22 first on my calculator, and then I would hit the second function button, which on this particular calculator is green, and then I would hit the log button to get the green 10 to the x. So log / 10 to the x, right? So log is what the button says, 10 to the x is what shows in green right above it. And that's giving me 166. We'll just leave it at that. For the scientific calculators that use the same keystrokes as the graphing calculators, you would want to hit the 10 to the x first, which would probably be a second function. So you would hit the second function and then the log key / 10 to the x. And that will open it up on the display with an open parentheses. Then you would type in the 2.22. Then you would need to close the parentheses and hit enter. All right, for this next one, I type in 0.0222, second function 10 to the x, and I'm going to get 1.052. And for the last one, I would type in the 2.22 and hit the change sign key to make it negative. Then I would hit second 10 to the x, and this is going to give me 0.00602. Okie doke. Hopefully you were getting those numbers. If not, come see me in office hours and let's figure out what's going on with your calculator. All right, now here's the other way that logs and 10 to the x are going to pop up. We're going to end up with an equation that says log of x is equal to a number, and we need to solve for x. Well, remember that log of x and 10 to the x are opposites, right? So the opposite function is 10 to the x. So like if you're multiplying and you want to get rid of it, you divide by it. Well, if you've got a log of x, you take 10 raised to a power. So, and of course, if I do it to the left side, I have to do it to the right side. So I'm going to take 10 and raise it to the power of the log of x. And I have to do that to the other side as well. So 10 to the 7.77. Well, the 10 raised to the log cancels out, leaving just x on the left side. So x is 10 to the 7.77. And let me run that through my calculator. 7.77, second 10 to the x. I get a pretty big number. I'm going to put that in scientific notation. I'm going to get 5.89 times 10 to the 7th. One more example. Over here on the right, we have that the log of x is equal to negative 2.75. And so I need to do 10, raise 10 to the powers of the two sides of this equation. So we'll do 10 to the log of x is equal to 10 to the negative 2.75. 10 and 10 raised to the log cancels out, leaving us just x over on the left. So x is equal to 10 to the negative 2.75. And so typing that into my calculator, I've got 2.75, change the sign, and then hit second 10 to the x, and I get 1.78 times 10 to the negative 3. Again, practice with these and make sure you're able to solve for x and run it through your calculator correctly.